Dear viewers, welcome to another video in the series of Minitab tutorials. As part of this playlist, we are understanding about the statistical application Minitab, the different tools and techniques and graphical representations available in Minitab. In today's video, we are going to understand an option called standardize. So how do we use this option standardize? What are the benefits of using it? That's what we are going to see in the video. Standardize is an option which helps us to transform the dissimilar columns with the different types of average and standard deviation, so data measured in different scale. So if you want to bring them to a common scale and try to use those standardized value for your analysis, we can use this option. Let's get into this video and understand about this in detail. As I was explaining in the introduction, standardize is an option which Minitab provides us to standardize unstandard columns of data that have difference in their central tendency or the scale in which it get measured, so that once it gets standardized, we can more easily compare the columns of data or analyze the columns of data together. So this option is available in Minitab, and we can store the standardized values in new worksheet. So here there is a Minitab example that is given where height and weight of samples are collected, and from that what is the pulse rate. So for different height and different weight, what is the pulse rate? That is what we are measuring. So height is measured in a different scale, weight is measured in a different scale. So when we standardize, we'll be able to convert height and weight more or less to a similar scale. So that is the example that we see here, but we will understand it with the different examples as we get into how to do this option in Minitab. Now here I have Minitab. I am going to click on cal, I am going to click on random data, and I am going to say generate random data. So I'm going to generate 100 numbers of random data and store it in column C1 with an average of 50 and standard deviation of 3. So I save this and let me call it as D1. So this is data 1. I'm going to generate another set of data points and store it in C2. This time the average will be 30 and the standard deviation will be 1. So let me store it in column C2 and let me call it as D2. Now if you see these two data, just to make you understand that they don't have same average and they don't have same standard deviation, if I click on graph and if I go to histogram, and here in histogram I select multiple histograms on the same scale, and I select my D1 and I select my D2 and then I say OK, you will understand that the central tendency and the variation for these two data are not similar. They are two differently collected data. Their scales are different, right? So the scale of one data and the scale of other data is different. For some reason, if I want to standardize this data, then what Minitab gives me as an option is I will be able to click on cal. Here I have an option called standardize. So when I click on standardize, I can standardize this data in multiple ways. We will understand about each of this one by one. So I can standardize this data in multiple ways. The first option that Minitab gives us to standardize is you can standardize this D1 and D2 using something called Z-score. So what is Z-score? I have clearly explained what is Z-score in one of my previous videos. I will share the link in this video description. Z-score is nothing but you find the difference between the data point from its average and then you divide it with the standard deviation. So x minus x bar divided by standard deviation will give you your Z-score. So if I select D1 and D2 and then I want this resulted value to be scored in C3, okay, C4 and C5, right? So I select this option, right? Subtract from mean and then divide by standard deviation, which is nothing but a definition of Z-score value. So now when I select this option and then click OK, just a minute, let me look into it. So C4 space C5. So here I have this data D1, D2, but it is standardized. So standardization technique 1 is being used. So I am using underscore S1 underscore S1, right? Okay. So now if I go to graph and if I try to select histogram and if I choose multiple histograms on the same scale, and then use D1 standardized using S1 and D2 standardized using S2, and then if I click OK, you will be able to see both the data are now pretty much in the same scale. The data got standardized and both the data are pretty much in the same scale. So this is what we call it as standardization. So original scale of the data can be something else in terms of its central tendency, in terms of its variation. The original scale can be something else, but you will be able to convert it into a standardized value and then do whatever calculations we want to do. So this is one commonly used method, which is z-score method. The other method would be, so I click on cal, I click on standardize, and now I can have the same data, but I want it to be saved in, let's say, C7 and C8. So the data to be saved in C7 and C8. And now I say subtract from mean. This is another option of standardizing. So which is nothing but you take an average. This is called mean deviation. How far is your data away from your mean? So in the earlier case, we have told to subtract from mean and then divide by standard deviation. But in this case, we are saying just subtract from mean. Calculate the average for your data. Then you see how far is your data point, x minus x bar. So this can result you the mean deviation. How far is your data deviated from the mean? So I select this option and then I say OK. So what will happen is this data will be standardized. So now the second technique of standardization that we have used is which is mean deviation. So I call it S2, standardization technique 2. So here also we will say standardization technique 2. And now if you see how well this data got standardized, we can again click on graph, we can go to histogram, and then we can select multiple histograms in the same scale. This time I can choose my D1 using standardization option 2 and D2 using standardization option 2. And now if you say OK, again the data got little bit standardized in terms of its average alone, not in terms of its standard deviation. So if you see here, the standard deviation is still widespread. However, the central tendency is more or less close, because your average, how far it is deviated from the average, that value will be at 0, because you will have positive values and negative values. So this is one another way where the average is more or less standardized, but the spread is not standardized. In the previous example, you saw both the average as well as standard deviation. From both the parameters, the data got pretty much standardized. So that is the difference between these two. The third option of standardization is I can click on cal, I can go to standardize, and this time again I can choose my data 1 and data 2. This time I can request the data to be saved in C10 and C11. And now what I'm saying, divide by standard deviation. So I'm not going to have the average, or I'm not going to use the parameter mean. I'm only going to divide by standard deviation. So I say divide by standard deviation, and then I give the storage column as 10 and 11, and then I give OK. So the new data will be saved here. So what is happening, the data is simply getting divided by its standard deviation. Whatever is the standard deviation for the data, it is getting divided by the standard deviation. Now if I say this as standardization technique 3, standardization technique 3, and now if I click on graph, histogram with multiple graphs on the same scale, so I choose this option D1 underscore 3, D2 underscore 3, and then I click OK. You will understand the standard deviation of the multiple data sets have been pretty much standardized. The standard deviation is standardized here, if you see here, whereas the average is not standardized. They are at two different places. The central tendency is not standardized. If you want to understand this in detail, the very first option we used a z-score method, where both average and standard deviation got standardized, and thereby you got that kind of data. So this is original data with both average not standardized as well as standard deviation not standardized. In the second data, we have standardized both. In the third data, we have standardized average, but we have not standardized standard deviation. In the third data, we have standardized standard deviation, but not average. Now let's understand the other two options. So I click on I click on cal, I move to standardization, right? This time I'm going to keep data 1 and data 2 here, right? But my storage location will be C13 and C14. C13 and C14. And the method I'm going to use is, if you see the first option, it says subtract from mean and divide by standard deviation. So instead of subtracting from mean and dividing by standard deviation, I can say subtract from 25 and divide with 5. So instead of me giving a common value, I am giving a, or instead of me giving a value from the data like average and standard deviation, I can give one positional value for average and one normal standard deviation value. So these two values, instead of taking it from the data, I can give a common value and then I can ask Minitab to do the calculation. Then what happens? Then Minitab will calculate and give me the data here. So we will call it as standardization option 4. So we will change this to 4, S4, and this also we will change it to S4. Right, so let me click on graph, let me click on histogram. So select this multiple histograms. So we will take this option and we will move on to standardization option 4, and then we click on OK. So now what happens? Now you will be able to get this data, but this data is not giving the results that we are looking for. This data got standardized, but in terms of average as well as in terms of standard deviation, it is not getting standardized the way we want, right? So this method is generally used when you expect a target average and target standard deviation, right? But two machines are operating with a different average and different standard deviation. With respect to target, we would see where it is. So that is where we have given these values, but this does not give the result that we are looking for. Now we'll go for the fifth option of standardization, which is nothing but trying to convert the data into a linear scale. So what do we mean by that? So let me click on cal, let me go to standardize. So this is the fourth option, and in this fourth option what we are saying, convert my data in such a way that the maximum value becomes +1 and the minimum value becomes -1. So what is the meaning of this? Let me first explain this, and then I will also change this maximum and minimum value to make you understand better. So as of now, I say my maximum value should be +1 and minimum value should be -1, and the new data to be stored in C16 and C17. So I select C16, I select C17. Now I click OK. So this is my this is my standardized value. I call it standardization technique 5. So in the standardization technique 5, what is this data all about? Let's understand. So this is standardization technique 5. So I am changing the column header, right? So to make you understand how does this data work, instead of using a graph, let me take this data to an Excel to make it easy for you to understand. So let me copy and paste this data in an Excel here. So this is D1, D2, the original data, and this is D1 underscore 5, that is fifth technique, and I will copy this data and paste it here. Now what does this data means? So if you see here, this value is represented as -1. So for example, if you see 26.59 is represented here as -1. What is the meaning? The meaning is, if I say is equal to minimum of, and then select this entire data, the minimum, sorry, let me delete this. Yeah, so the minimum value was 26.598, and now that got replaced to -1. So that is a minimum value, right? And similarly 33.15, and that, if you see, is equal to max. Select this entire data, close brackets. What will happen? Your maximum value got replaced with +1. What is the meaning? In this particular data, let me sort it. So I sort this data only, data, sort, continue with current selection. I say sort, D2 value, smallest to largest. If I say OK, 26.59 will be my minimum value, and if I scroll down, 33.15 will be my maximum value, right? So now I'm going to sort only this data, D2 underscore S5. So I click on data, I click on sort, continue with the current selection, smallest to largest, I say OK. So -1 will be your minimum value, and plus 1 will be your maximum value. So this is how this data got sorted. And same technique will be applied to your data 1 also. So let's select this data and we will say data sort, continue with the current selection, smallest to largest. Minimum value will be 41.11 and maximum value is 58.69. So if I select this option and then go to sort, continue with current selection, sort, I will say smallest to largest, your minimum value will become -1 and your maximum value will become +1. Now what happens? Your data, it can be in any scale. Your data can be in any scale. However, I can convert it into a linear scale of -1 to +1. And you will have all data points only between -1 to +1. So the conversion equation or standardization equation is derived in such a way that your data get converted, whatever be your minimum and maximum value. Now your minimum and maximum value will fall between -1 to +1. So this is what the fifth method of standardization. Now let me go back to my Minitab. So if you see this particular way of standardization, again if you click on graph and then if you click on histogram and if you select multiple histograms in the same scale and you choose D1 S5 and D1 S5 and then if you say OK, you will find that the data is getting perfectly standardized, both in terms of its average and in terms of its standard deviation. The data is getting perfectly standardized. So one another option that we can do is within this I can click on cal, I can go to standardize and I can go to this last option, but instead of calling -1 to +1 I can say data of 20 to 25. So starts from 20 and end to 25. Then what will happen? So both the data in D1 and D2, whatever the scale in which the original data get collected, but the standardized data which we are going to save in C19 and C20, the standardized scale data will fall between, so I make it 19 and 20. So start is 25, end is 20, start is 20 and end is 25. Now what you see here, so this I can call it as D1 standardized using technique 5_1 because earlier we had -1 and +1. Now we are having 20 and 25. So this is how the data got sorted or standardized. So now if you click on graph histogram with multiple graphs and then you select these two options and click OK, you will find that the data is only between 20 to 25. The minimum value will be somewhere close to 20 and the maximum value will be somewhere close to 25. So friends, this is the technique that Minitab gives us to standardize data collected in different scales, data collected with a different central tendency, data collected with a different average. But if for some analysis purpose, if you want it to be standardized, this is a technique by which you can first standardize them, and then based on the standardized value, you can subsequently use your other statistical techniques, right? Hope this video was useful. For more videos on Minitab tools and techniques, graphical representation and quality management videos, please subscribe to our channel. Thank you.